So in this question here, we've got a situation where a gardener is designing a flower bed. And this is the general shape of the flower bed. Now, what it consists of is a base of length 4x meters, two heights of this particular rectangle part of being w meters, so w is a variable we're going to find. And here we've got a semicircle, and it's got a radius of x in that semicircle. Now, the area of the flower bed is to be 100 square meters, so the whole of that, 100 square meters. Now, what we want to do in this question is find w and find the perimeter, or find an equation of regarding the perimeter and the length w. But also, we need to calculate the minimum cost that the gardener would need for the fencing to go all the way round, with these rules in mind. Obviously, the key one is the area to be 100 meters squared. So this is a minimisation question. And then at the end, we're going to work out what the cost of the fencing will be at £12.75 per metre of the fencing. So when it's a minimisation question, we know derivatives are coming up at some stage. And as it's the cost of the fencing will go all the way around. We need to, obviously, the key part is to find the perimeter, which we're going to do here. And we can't find the perimeter until we've found some sort of representation of W. So let's do that. So first of all, the flower bed is to be 100 square meters. So let's calculate the area. So first of all, so A equals, well, the area is going to be 100 meters squared. So we can set that to 100 straight away. So we know what the area is. All we need to do now is work out what the formula for it is. So here we've got a rectangle, 4x by w. So we've got 4xw. And we've got a semicircle here. Now that's half of a circle. Area of a circle is pi r squared. In this case, the radius is x, so it's going to be pi x squared. But it's only half of the circle, so it's pi x squared over 2. So that will be added on to our area. So pi x squared over 2. Now here, pi is a constant, x is something that we're going to need to find our particular perimeter, but we can isolate the w already. It says to find w, so we can do that from this equation here. So let's isolate that. So let's bring the pi x squared to this side. So I've got 100 minus pi x squared over 2 equals 4x w. Now, just a little bit awkward with this 2 here, so I'm going to multiply everything by 2. So that's then going to give me 200 minus pi x squared times this by 2, literally going to have 8x and w. Now I can simply isolate the w by dividing by 8x. So I'm going to write it here like this. W equals 200 minus pi x squared over 8x. Now I'm going to divide everything by the x's, try and get the x's in 2 different terms. So that will give me w equals 200 divided by 8 is 25. So that's 25 over x. And then pi x squared over 8x, that's going to give me pi x divided by 8. Okay, now I need to calculate my perimeter. That's the next stage. So perimeter, how can I do that? Well, that's just literally what we've got going around the edge of this particular garden shape. So I've got 4x, so right, p equals 4x. I've got w and w, so I've got 2w. Now I've got this here, which is a semicircle. Now the radius of the semicircle is going to be x. So both them are length x. Now the perimeter of a circle, or the circumference of a circle, is 2 pi r. In this case, the radius is x, so it's 2 pi x. But I've only got half of it, so it's just pi x. And then I just need the length here. Now, if these 2 lines there are both radiuses, that means that's 2x. Well, this is 4x, so these 2 must be combined to make 2x. And it doesn't even matter if this is in the centre or not. If this is slightly off centre, you've still got 2x left. So that would take care of the perimeter. Now I've got x, x, x and a w. But I've got my w here, so I can write that, plug in my value with w, and then I've got everything in terms of x. And then that's going to help me with my minimization part. So let's simplify this. So what have I got? I've got 4x, pi x, 2x. So basically I've got 6 plus pi times x, and then 2 lots of w, plus 2 times w, which is this. So 25 over x minus pi x over 8. Okay, right, to make my life easier, I'm just going to FOIL this out, multiply by 2. So then I've got 6 plus pi times x, then multiply by 2, I've got 50 over x. And then here, 2 times that, well, that just be pi x over 4. So it's minus pi x over 4. I'm going to write that as minus pi over 4x, because then that will fit in quite nicely here. So I've got 6 plus pi times x minus a pi over 4x. So that's literally just going to give me 3/4 of a pi. So let's write that. So now my perimeter equals 6 plus 3/4 of pi times x plus 50 over x. And now I'm in a good position, because all I need to do now is to take the derivative, and I've got my minimum. So whenever there's a minimum, it always involves a derivative. So let's take the derivative of that. So let's do this down the centre. Okay, so I want dp with regards to x. So dp dx. Let's take the derivative of that with regards to x. Well, with regards to x, that's just a constant, so I'm just left with that. So I've got 6 plus 3 pi over 4. And then the derivative of that, that's basically 50 to the x minus 1. If I just write that in brackets. So then basically multiply by the minus 1 and drop the power by 1. So that's going to give me minus 50 x to the minus 2. So that's going to give me minus 50 over x squared. Okay, now as that's a derivative and I want to find my minimum value or maximum value is always when this is 0. So what I require is derivative of p with regards to x equals 0. So if I set this to 0, I can get my x value. So then I've got 6 plus 3 pi over 4 minus 50 over x squared equals 0. Bring this over to this side. So 6 plus 3 pi over 4 is 50 over x squared. Now all I've got to do now, by doing the cross multiply method, is change places with the x squared and all of this and take the square root. So then I'll have x equals square root. I'll have my 50 and then divide that by, well, if I put them both over 4, so that'd be 24 over 4, so just change that to 24 over 4. That'd be easier to write. So then I've got 24 plus 3 pi over 4. And if I put that into my calculator, I'll get x is approximately 2.44-ish. So x equals 2.44. I think the third digit is 6. So put in that calculator and check. So that's your x value. Okay. So now that I've got that, I can work out what my perimeter is by simply putting x into that. So if I've got that, my perimeter, let's just put my perimeter calculation here. My perimeter equals 6 plus 3 pi over 4 times this 2.446. Now keep your calculator value stored in there, so when you plug that in, don't get a rounding error. And then I want plus 50 over 2.446. So use your answer button to get those numbers to be completely accurate. So if I get that and put that all in my calculator, I should get around about 40.88. So the perimeter is 40.88. Now that, because it's a derivative, should give me the minimum value. Now I just need to do a little check here and make sure this is my minimum. So what I need to do that is take my second derivative and make sure, as a minimum, it must be greater than 0. So now we've got the perimeter. Now what I need, let's keep that there. So now I need the second derivative of this. So 6 plus 3 pi over 4, that goes. This is now literally, if I just write that over here, underneath there, let's put it in their little box. I've got minus 50 to the x minus 2. So my derivative, I've only got to need this term because that's going to disappear as a constant. Multiply by minus 2, so that's going to give me plus 2. So that's 2 times x over, that's going to be x to the minus 2 will become x to the minus 3. So I've got 50 times 2, that's going to give me 100. And divided by x cubed. Now whatever value of x I plug in there, that's always going to be greater than 0. So x can't be negative. So therefore my minimum check is sorted. Okay, now the last bit is calculate the minimum cost of the fencing, 12.75 per metre. Well, I can't do 40.88 times that because when you buy stuff it has to become in whole metres. So assuming I can buy it per metre, I need 41 times that. So this one is 41 metres times £12.75. And that should come to £522.75. So that would be my minimum cost. So that's the answer to that. And for W and my P, this is my expressions for W. So I'm going to use either of those. And my expression for P, I'm going to use this one. So that's my P value there. Actually, we use this one. This one's the more simplified. So that's the one there. In fact, let's highlight them in green. So that's my W, that's my perimeter, and where did we find our x value? We isolated the x, and my x is there, perimeter is there, and total cost is there. Okay, that completes the question.